The final example in this section is a fun little puzzle that asks, is it possible to have 50 coins made up of pennies, dimes, and quarters that all add up to $3? If you think the answer is yes, can you provide the combination of pennies, dimes, and quarters? If you think the answer is no, can you provide the reason why? Can you justify your answer, basically? So pause the video here and try for a couple minutes to find a combination of 50 coins made up of pennies, dimes, and quarters, and see if you can find 50 coins that add up to $3. You probably discovered that this is not possible. As a matter of fact, the statement in this problem is actually false. It is not possible to find a combination of 50 coins made up of pennies, dimes, and quarters that adds up to $3. So in order to do the proof, I'm going to start by saying, suppose there is a combo that works. Then I'm going to show that this leads to some crazy nonsense. So I'm going to pretend like there's a combination of pennies, dimes, and quarters that adds up to $3, and it's made up of 50 coins. So P is the number of pennies, D is going to be the number of dimes, and finally Q is going to represent the number of quarters in the combination. Then what I know about this is that P plus D plus Q has to add up to 50 coins. I'm only allowed to choose 50 coins, and I have to use all 50 of them. No more, no less. Now the value of my money is this. Each penny is worth 1 cent, or in other terms, $0.01. The dimes are 10 cents, or $0.10. And finally, the quarters are $0.25, or 25 pennies. So the total of my money has to add up to $3, and the number of coins has to add up to 50 coins. Now to make life a little bit simpler, I'm going to multiply the second equation by 100 to make the numbers nice integers. And I'm going to pretend like I have a system of two equations. The first one is here, the second one is there, and I'm gonna just see what happens when I subtract those two equations from one another. Subtracting them gives me 3 times 3D plus 8Q is equal to 250. Now how is that useful? It's useful because the D and the Q were the number of dimes and the number of quarters in my combo. Remember, these numbers cannot be anything other than integers. We're talking about numbers of coins. You cannot have half a coin. You can only have 1 or nothing, or 2 or nothing. So these are both integers, and multiplying by 3, multiplying by 8, and adding them up will still keep everything as an integer. So what I've discovered right now is that 3 times some integer is going to be at the end equals to 250. So what I'm saying is 3 actually divides 250. But wait a second. 250 is 2 times 5 cubed. Right? 125 times 2 is going to be 250. And 3 does not show up in the prime factorization anywhere. So this leads to what's called a contradiction. So this is the crazy nonsense that we were talking about. Contradiction is that 3 is dividing 250, which is not true. This is according to the fundamental theorem of algebra. So what does that mean? That means that there is no combination of 50 coins made up of pennies, dimes, and quarters that adds up to $3, unfortunately.